When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. What we're going to do in this video is we're going to cover this exam question, which comes from the acids and pH scale chapter. What I'll do in a second, I'll read the actual question. Once I read the question, give about 5 seconds to pause the video. Once you've paused the video, attempt the question, and then press play when you're ready. This is the question itself. So the diagram shows 3 reagent bottles containing acids. First one, it has 0.01 molar of acetic acid. It has a pH of 3.38. The second one has a concentration of 0.01 molar per liter of citric acid. That has a pH of 2.56. And the third one has a pH or a molar concentration of 0.01 mole concentration per liter of hydrochloric acid, and that has a pH of 2.0. The questions are A. Calculate the pH after 10 mils of 0.01 molar per liter hydrochloric acid solution is diluted by the addition of 90 mils of distilled water. B. Explain the use of acetic acid and citric acid as food additives. That's worth 2 marks. And C. Explain the difference in pH between the 3 acids in the diagram. So between these 3, and that's worth 2 marks. So when you're ready, pause the video and attempt the question, and press play when you're ready. Welcome back. Alright, so for this question, the first thing you should know is how we can calculate new concentrations. And there's a formula for that. It goes C1 times volume 1 equals C2 times volume 2. So what that means is our initial concentration and volume, which was 10 mils and 0.01 molar, goes here. So concentration stands for C. Concentration was 0.01 mole per liter. And our volume was 10 mils, so times 10 mils. And now what we actually want to get is we want to get a new concentration once we've added 90 mils. So the concentration, C2, that's what we're trying to get. We don't have that yet. But we know the volume because in this case we've got 10 mils initially. And we added to those 10 mils, we added 90 mils. So 10 plus 90 is 100. So our new volume is going to be 100 mils. So now we have everything we need except for the concentration, but if you can see, we can actually rearrange that formula to get our new concentration. So what we do is we bring 100 over to the other side by dividing both sides by 100, and then what we get is a new formula which goes like this: 0.01 mole per 10 mils divided by 100, because we divided both sides by 100, which means it goes away from here and it goes down here, equals our new concentration. If we type all that in our calculator, we get the new concentration of hydrogen ions in our solution. So that's 0.01 times 10 divided, that's 0.1, and then divided by 100. That's this part here. That equals to 0.01 mole per liter. So our new concentration is 0.001, is that right? Yep, 0.01 moles per liter. And now all we have to do is we have to use our concentration to get our pH, because it's asking what is the new pH. And remember that the formula for pH was pH equals minus log to the concentration of hydrogen ions. In this case, our concentration of hydrogen ions is now 0.01 mole per liter. So all you have to do is you have to put those numbers in. So you would type in your calculator as pH equals minus log, and then you have 0.001. That's in calculator, and then what you get, because my calculator doesn't do logs, so I can't do it in the calculator. I should get a new one hopefully eventually. But yeah, what you would get is you get a pH of 3, which makes sense. I mean, that's what you should be expecting, because in the question itself, you had pH of 2 to begin with. You had this solution to begin with, that's a pH of 2. And all you added is you added water, so you diluted it. So you'd expect there to be a smaller concentration of hydrogen ions, which means a higher pH. That's where you get any final answer. But yeah, all of this was actually only worth 1 mark. So they're actually pretty harsh on you for 1 mark for that question. Maybe that's a 2-mark question. But yeah, it's a 1-mark question. Next part was explain the use of acetic acid and citric acid as food additives. So if you name what they get used for, you get 1 mark. If you explain it, you get 2 marks. So we're going to name what they get used for and explain why they get used for those different purposes as well. So I wrote acetic and citric acid all lower the pH of food, killing bacteria. So that's one of their properties. They can lower the pH of food and thereby kill the bacteria, so they can be used as food preservatives. So now I've said that one of their uses is food preservatives, but I've also explained why they get used as food preservatives, because they can kill bacteria by lowering the pH. And that will get you 1 mark. And then I still also mention what citric acid also gets used for, apart from using it as a food preservative. So citric acid is also often used to make food more sour and enhance the flavor of food by making it more sour. So that's one of the reasons, that's one of the things it gets used for. And why? So the explaining part is, it's just the last part here. As acids produce sour tastes. So anything that's acidic makes it sour, thereby we can use it to make food more sour. And I will also get a mark. That's 2 marks out of 2. And the last one, explain the difference between the pH between the 3 diagrams. So here we have these 3 diagrams. We've got acetic acid, citric acid, and hydrochloric acid. And you should remember that hydrochloric acid was a strong acid, whereas acetic and citric acid were the weaker acids. You should also note that the actual concentrations were all the same. So it won't be a difference in concentration. It'll be a difference in the strength or the weakness of the actual acid. So the degree of ionization. So what I should mention first is, or what you generally should know, doesn't have to be first, but to mention that the concentrations are all the same. So the change in concentration is not the reason why the pH is different. Concentrations are all the same. You should mention what the degree of ionization does, and that weak acids ionize less and strong acids ionize more, and thereby hydrochloric acid is the strongest acid, acetic acid is the weakest acid, and citric acid is in between the 2. That's what I wrote. So I wrote the concentrations of all 3 solutions is the same. So the concentration is not linked to difference in pH. So they're all of a different pH, but it's not due to concentration, because the concentration is always the same. And what I wrote next is pH is a measure of hydrogen concentration minus log H+. That's your formula for pH. Meaning the high concentration of hydrogen ions lowers the pH. So the more hydrogen ion concentrations we have, the lower our pH. And then I wrote hydrochloric acid ionizes completely, resulting in the highest concentration and the lowest pH. Right? So hydrochloric acid has most hydrogen ion concentrations and lowest pH. Acetic acid is a weak acid and does not ionize completely, giving it a lower hydrogen concentration and a higher pH. And citric acid is a weaker acid than hydrochloric acid, so it's weaker than hydrochloric acid, but stronger acid than acetic acid, and so has a pH between the 2. I don't think I actually wrote that, but yeah, it would have a pH between 2 because it's stronger than acetic but weaker than hydrochloric. So in this case, I've mentioned what the pH scale is, and that it has nothing to do directly with the concentrations of the acids, but more with the concentration of hydrogen ions. And then I mentioned that there will be more hydrogen ion concentration in hydrochloric acid because it ionizes completely, less in the other 2, and acetic acid has the least of them all because it's the weakest acid. So that gets you your other 2 marks. That'll be 3 marks out of 3. So actually, it's only worth 2 marks. Sorry, it's only worth 2 marks. But you get 1 for just quickly mentioning what pH is, and it's all about the hydrogen concentration, and then 1 mark for saying that hydrochloric acid will have the most hydrogen ion concentration, and acetic acid will have the least, and citric acid will be in between the 2, due to the fact that they don't ionize completely. Where these questions come from, they came from these dot points. Compare the relative strengths of equal concentrations of citric acid, acetic acid, and hydrochloric acid. So these are the ones given: acetic acid, citric acid, and hydrochloric acid. And we also said it says compare the equal strength. We also have the equal concentrations. In each case, we also have the equal concentrations. And explain these in terms of the degree of ionization of the molecules. So that was basically part C. Came from that dot point. Describe acids as solutions with cooperative terms. Actually, I forgot 1. B, there was a dot point which talks about food additives, food additives. and what kind of acids get used as what kind of food additives, and that's where question B came from. B came from that point. But I hope that was useful.
Thank you for watching.